Well, welcome to AP Psychology. My name is Ms. Del Savio, and unfortunately I will not be here for a while, but I do want to get the class started off and just go over some of the basics that I would have gone over if I'd been there. Mr. Templeton will be filling in for me through at least Thursday. I am actually recovering from pneumonia. I'm not actually enjoying another week of summer. I would have loved to have enjoyed 1 week of summer without being sick, but definitely on the mend. Okay, a couple of things by now. Hopefully you've picked up the 3 packets on the table by the whiteboard. If you haven't, while I'm talking to the slide, please make sure you get all 3 packets. They're pretty big, and one of them is going to be used today, so we take notes. As far as your seats go, choose wisely. I may have to shift them just because some people need to be a little closer to the front. So I'll take care of that when I get back. Also, some of you don't always pick the right seats, so you end up maybe being in the back of the room when you maybe should be in the front, or you sit with people who you tend to be chatty with, and that's not going to be the best decision for you, but we'll see when I get back. Obviously, as in all classes, you'll need to put your cell phones into the pockets, and for now just put them into any pocket. When I return, I'll assign you to a pocket for this week. Just pick anything, and in the future I will be taking attendance based upon the cell phones being present in those pockets. Okay, so hopefully you've picked up your packet. What you haven't seen yet, or maybe you have, is on Canvas. We have everything already published for you, ready to go for this unit. It's a nice long unit. We have a lot of time to sort of get into what is psychology, talk a little bit about research methods, and teach you a little bit about the basic statistics that we need, and also look at the different perspectives of psychology. How do different psychologists explain behaviors? So the calendar that you see up here is posted in our module. It's also reflected in our Canvas assignments, and I do update it to reflect our daily instruction. So the blue is all practice prep, and it'll be handwritten in a packet that you just picked up. The red are all task assignments, and let me go over a little bit about the dates on these. And I most particularly want to go over these practice prep dates. Right now, I don't know how long it's going to take to get through each instruction. So I have due dates on the calendar, I have due dates in Canvas, but to be clear, you'll need to be flexible, and I will be too. We have to cover the material before you can do these practice prep assignments. And since most of them are completed in class, like I said, we'll have to see where we go. So don't work ahead. Don't worry about it. If you miss one for this particular unit, we'll just be very flexible. But in general, as we move forward, you should be aware that our deadlines in AP Psychology are 2 days after the due date. So if you are absent for an assignment that we did in class, or there was one of these practice prep assignments that was to be done as homework and you don't turn it in, you have 2 days after that. Otherwise, you pass the deadline. Now for the all task assignments, those are mostly assessments that are done in class, and those dates are not likely to change. I would suggest you communicate planned absences before an assessment, and if you've missed an assessment, just make sure you talk to your teacher. There are a few projects that will come under this category, and again, it will just be a deadline of 2 days after the due date, just like the practice prep. A lot of question has to come about for reassessments. I know this year every teacher is mandated to assign 2 reassessments, a minimum of 2 for each quarter, and it can't be some kind of end of quarter assessment. We don't really have those, so we'll pick at least 1 per unit, and usually we have 2 to 3 units in a quarter, so that works out really well. We don't really need reassessments for our practice prep. They're mostly done in class, and they're completion assignments, so we're not going to have to reassess those. Now, as far as what reassessments look like, they could be timed test corrections, like you come in at lunch, we do it in class, and you get partial credit earned back. And the way we do test corrections in this class, since most of our tests are on Canvas, is under lockdown browser. So you will have to bring your Chromebooks, but you will take a test, and then it will only deliver to you the questions you got wrong, and then you'll answer those hopefully correctly and get partial points back. Now, in some cases, we don't do that. We just give you a brand new assessment, and in that case, there will be new questions, and the highest score is kept per MCPS policy. So the advantage is always on your side to take advantage of a reassessment. Now, for all these all task assignments, it's obviously a big issue if you miss an assessment. If you miss one, you've probably missed a few in every class. So it's always best to communicate your planned absences ahead of time. I would much prefer to say to you, hey, let's just take off 6 questions that you didn't have a chance to study for, because we're going to give you the test early. And then you just get those 6 points. Okay, let's just get that over with. And that way you're not coming back from an absence to a lot of assessments. So always communicate as much as you can. The other thing is, if you do miss an assessment, MCPS policy is that we don't have to assess you in the same format as the original one. And sometimes, especially if you've waited a long time to take the assessment, it's possible that we'll have to give you, let's say, not a multiple choice one, but a short answer one. So please, please, please communicate for everybody's sake. And like for all task assignments that are out of class, that are maybe projects that we give you, if you do miss the due date, an alternate assignment may replace the original. So as always, there's always an opportunity for teachers to use a different assignment than the one that was originally given if you are late on it. Okay, so try to be on time, but more importantly, try to communicate ahead of time. A lot of you are involved in sports and other activities like the play, and we just need to know ahead of time what your schedule looks like. We can't always accommodate it, but we will definitely do our best to do that. Okay, we're ready to sort of take some notes, and I do want to spend time when I return getting to know you and doing some more warm-up activities, but since I'm not here, I am going to take advantage of this time to have you get introduced to the subject of psychology. So take out that AP Psychology Students Notes packet, and we're going to go over the field of psychology, the role of critical thinking, and biases. I'm going to start as what is psychology? So you've taken or decided to take this class, and you probably have in your head what you think a psychologist does. And maybe some of you think it's just a person in a room talking to another person. Maybe they're laying down on a couch and they're asking them questions, and they're helping them solve problems. And that sure is part of psychology. But psychology is a science, and even that therapist in a room is using science-based practices to treat their client. So psychology is the study of behavior and mental processes. As you're writing down this definition, I want you to think, what is the difference between a behavior and a mental process? Okay. So behaviors are observable. Things like physical actions. So if I want to see how alcohol affects somebody's driving skills, I would certainly be studying behavior. Behavior are emotional responses. How does somebody respond when they're frustrated? How does somebody respond when they're happy? Okay. Respond, meaning how do they behave? What can I observe? How do people interact with each other? How they interact with each other, how they act maybe differently when they're in a crowd. And then there are behaviors that are learned. How are behaviors that, let's say somebody, or actually I'll ask you all, how many of you brushed your teeth before you came to school today? And I'm going to say all of you did. You did not come out of the womb with a toothbrush and ready to brush your teeth. You didn't even have any teeth, but you did learn that behavior. And I can also ask you how many of you do your homework as soon as you get home, or how many of you make your bed, or how many of you do chores around the house. These are all behaviors that were somehow learned, and those are observable, and psychologists are interested in how did you learn those behaviors. These are some of the questions that researchers might investigate when they're investigating behavior. Like, what are the root causes of discrimination? We know discrimination is a behavior. What caused it? What causes that behavior? What situational factors can increase violence? We often see people are more likely to be violent in a crowd. So what are those situational factors? Under what conditions will someone be altruistic? In other words, under what conditions will somebody do something for somebody else without expecting anything in return? So these are questions that a researcher might investigate. Can you think of maybe your own examples of observable behaviors that might be of interest to a psychologist? You can pause the video and just think about that and maybe answer that. Okay, let's move on to mental processes. Now, as opposed to behaviors, mental processes cannot be observed. They're inside the mind. And mental processes refer to things like cognition. Cognition refers to any kind of mental activity. When you make a decision of what to have for dinner, or you judge somebody based upon their looks, or you take an exam, or you process new information coming in. That's cognition, okay? That's a mental process. And of course, psychologists are very interested in studying those mental processes. Now, while we looked at emotion and the behavioral, the observable component of an emotion, there's also that internal experience. What actually is happening inside your head? What are you thinking about? Where's your brain or your mind go, okay, when you're experiencing emotion? Does the emotion come after you've evaluated the situation, or do you immediately feel an emotion? And then there's perception. How do we take any kind of stimuli that's coming in? It could be the flavor of a food, or it could be an interaction you have with your teacher. And how do you interpret it? Did you interpret it positively or negatively? And then motivation. Big question, of course, for all of you. How could you be motivated to perform in a way that makes you happy at school and happy with your friends and keeps your family happy? Like, what is that motivation that's there? Some people seem to go through life really easily. They're always motivated to do the quote-unquote right thing, and other people not so much. So what is that motivation that's driving people? And the questions that researchers might investigate when they're investigating mental processes are things like, what are the best study methods to improve recall? Wouldn't it be great if you knew how you could study and get to an exam and actually remember everything you studied? And we actually will be going over that in one of our units. What effect does stress have on health? We do know that the mental process of stress, and how, because that's partly how we perceive our world. Some people might feel stressed when they have one test. Somebody else might feel stressed when they have three. But what effect does it have on our health? That's a big question. And again, how do we motivate workers or students to be more productive? Those are questions that researchers might investigate. And you might be able to think about your own examples related to emotion or perception or motivation. So you could pause again and take some time to maybe come up with one more question. Let's move on talking about the scientific attitude. We'll talk about critical thinking and developing arguments. And you don't really need to memorize this for an exam, and you don't even necessarily need to write it down, but I think it is an important understanding of psychology as a science, or any science. The first part of any science is somebody was curious. Somebody said, oh, I think this is what's going to happen. And then they go out and they're so curious that they gather data to see if it supports their prediction. And then the scientific attitude requires that people are skeptical. When they come across a finding or somebody tells them about something that they believe to be true, they have to ask themselves, how does this person know that? I'm open-minded, it might be true, but I'd like to understand better how they collected that data, what they mean by that, and what does that actually entail. And finally, if you are curious, and then you have a healthy amount of skepticism, and you go out and you gather information, did you actually find that the information you gathered didn't support what you originally believed? So we have to be aware of our own vulnerability to error, to biases. And we have to realize it's way more important to seek the truth than being right. And I'm sure you know that person, you've argued with them, and all they want to do is be right. And all you really want to do is find out the truth. And it's hard sometimes to deal with people like that, right? Because they don't have that humility. But that's part of the scientific attitude. The scientific attitude does require critical thinking. In other words, not automatically accepting an argument as being true. We have to question conclusions that people come to. We have to attempt to evaluate evidence. It's one thing to question somebody's conclusion, but it's another thing to say, okay, well, let me see, how did they get to that conclusion? What is the evidence that they use? How did they gather that evidence? Is there possibly any reason that there's another reason for their conclusion other than what they think it is? So critical thinking is about questioning, okay? So we need critical thinking. And And you might ask why. I mean, doesn't everybody think critically? No, we don't think critically. How many times have you heard that opposites attract, or you've only used 10% of your brain? And if you weren't a critical thinker, then, or if nobody was a critical thinker, we would never have had the science behind it to say that this is not true. These are both debunked by real science. In fact, people who share a lot in common are more likely not only to be attracted to each other, but have enduring relationships. And we use all of our brain. Maybe not all the time, but we use all of our brain. Okay, so critical thinking allows us to question and then come up with real answers rather than just taking something we've heard as truth. So psychology is a science, and we have a need for it. And we have a need for it to be a science because we engage often in biases that are cognitive in nature. They're part of our brain, part of our mind. So when you hear cognitive, it's your mind. Cognitive biases are errors in thinking. There's so many of them, but in this class we'll just talk about a few. But these errors in our thinking influence how we judge people. It's influence how we make a decision. And these cognitive biases are the reasons why we need psychology to be looked at as a science. We need to study it scientifically. The first one's called hindsight bias. When we look back at something that's happened and we're like, oh, yeah, I could have predicted that. You'd say, well, it's so obvious, right? Of course you could have predicted, it's so obvious. But it isn't always obvious, and it's only because it's in hindsight that you think it's obvious. Like I knew it all along. It's like, seeing a waiter carry a tray full of heavy dishes and glasses, and then you hear a smash and all the glasses have spilled over, the waiter's on the ground, and you're like, oh, I saw him doing that. It was like so heavy, of course that was going to happen. And that's hindsight bias. You didn't really know that was going to happen. A really famous study was done called the Bobo doll study, and it wasn't a study about hindsight bias, but I'm going to use it to see if you might engage in it. A group of psychologists set up an experiment, and in this experiment they had children observing adults interacting with an inflatable clown doll. It was called a Bobo doll. When I was very young, it was a very popular Christmas toy. I remember getting one for Christmas. And then you blew it up, it had a weight on the bottom, and you could hit it and it would bounce right back up. Actually, I have one in my closet that I'll blow up when I get there. Anyway, in one of the conditions, some of the children watched an adult model. Just when I say a model, I mean somebody who was part of the experiment, that behaved very aggressively towards the doll. They hit it, they kicked it, they shouted at it. In another condition, the children watched an adult model behaving non-aggressively. They quietly played with the toys and they ignored the doll. I think they may have also played with the doll, but they didn't play meanly with the doll. Anyway, afterward, the children were given a chance to play with the same toys, including that Bobo doll. So they went into the same room and they got to play with the toys. The question is, did the children who saw aggression imitate it, or did they resist copying the adult's behavior? What do you think? Okay. Now, I will tell you that the children who saw the model play aggressively with the Bobo doll engaged in more aggressive play than those who watched the model either not play with the doll or play nicely with the doll. And you can say, well, that's so obvious. Okay, and I don't know how many of you actually thought that, and those of you who did think it might have said it was so obvious. But remember, it's just as likely that the children would have been scared by the model's behavior towards the Bobo doll and played nicely with it. You can't really know. I mean, the only reason you know now is because I've told you, and maybe some of you hadn't come to a conclusion, but then once you read my conclusion, you're like, oh, of course. That's an example of hindsight bias. Okay, another one's overconfidence. So we tend to be more confident than we are correct. And that's what I would write down here. So we tend to be more confident than we are correct. And I'm going to do a little exercise with you. I'm going to see what you think. So I'm going to ask Mr. Templeton first, while you're writing this down, to count how many people are in the room right now. So he has a number, Mr. Templeton. How many people are in class right now? And then what I'm going to ask you to do is to put your head down on the desk, and you're going to raise your hand if you agree with the statement. Okay? So go ahead and write down overconfidence. And let's go ahead and pause the video. When you're ready, you can move to the next slide, and Mr. Templeton, I will read out, or you can read out what's on the next slide. Okay. So before I move on, I'm going to pause the video and make sure you don't unpause it till your heads are back on your desk, because I don't really want you to see what everybody else is answering. Okay, so either I'm asking you, Mr. Templeton, is raise your hand if you think you are better than the average driver in this classroom. So as you maybe don't know everybody, but if you could guess, are you better than the average driver in this classroom? Just raise your hand if you say yes, and then Mr. Templeton can count that. And you'll see how many out of the whole number actually say yes. Okay, you can put your hands down when he's done counting. Okay, the second question, again, heads down. Are you more ethical than your peers? Do you think if you were to compare your ethical behavior to your peers' behavior that you have higher than average ethics? And only raise your hand if you say yes. And again, Mr. Templeton will be counting. So maybe you've been able to sort of gather the data, but the question is, did more than half of the class answer yes? And if more than half of you answered yes, you know mathematically it's impossible that 50% of you are better than the average driver in the class. And it's impossible that more than 50% of you are more ethical than your peers. Okay, it just doesn't work that way. That's just the law of average. So you might have, maybe we demonstrated overconfidence in this class, but those are the types of questions I'd ask. Now I will say that studies were done in the United States, and in Americans, 65% of Americans believe they are above average in intelligence. And in Sweden, 77% of the drivers rated themselves as safer than the median driver. Okay, again, overconfidence. Now, I always question why. Why is that true? Is it the framing of the question, like when you say better than average? Because I know a lot of people see average as mediocre. I don't. I think average is great, but average is mediocre. And maybe that's overconfidence. Okay, confirmation bias. Like the phrase sounds, we tend, and I'm going to just ask you to write down what's on the bottom of the screen here. We tend to seek information that supports our beliefs. We often, and maybe unintentionally, want to believe we're right. So we go out and let's say I believe, and I do believe, that the smoking marijuana or using edibles at your age is damaging to the brain. The teen brain is a growing brain. I don't think any chemical substances should be introduced into it. That's my belief. Now, if I were engaging in confirmation bias, I would go to Google and I would say, show me the studies that are done where it shows that marijuana or THC is bad for the teenage brain, or is THC bad for the teenage brain that's still growing? I'm going to likely find that all the results I get are going to support what I just searched for. That is confirmation bias. We do it all the time. I even do it as a teacher. I don't even mean to, but I might think that in the class that all the noisy kids are the kids that tend to sit in the back of the room. So anytime there's noise, I look to the back of the room to see if any student's talking. Now, even if everybody's talking, I'm only looking to the back of the room. So of course I'm going to confirm my belief. Okay. So confirmation bias is a pretty important bias, cognitive bias, that can impact our way in which we conduct experiments. So we have to do experiments so that we can get rid of biases. Okay. I'm assuming we still have time, day one, so I'm going to move on to talking about theories and hypotheses. So we're going to talk about what is a theory and what is a hypothesis, first of all. But first of all, before we do that, in psychology as a science, we have to look at the scientific method as being a self-correcting method. It's because we conduct research, we observe, we analyze, we look at the data we have, and we correct our assumptions if the data doesn't prove what we think to be true, or it just shows us something different than what we thought to be true. Now, in the field, or any science field, including psychology, you will often see journals that are published, online as well as print. These journals are peer-reviewed journals. Peer reviewers are experts in whatever field it is that's being published. If you're a developmental psychologist, then you would be peer reviewed by other developmental psychologists. And they ask questions like, did the study follow the scientific method, which we're going to be going over? Are the conclusions valid? In other words, are they accurate? Are they consistent? Was the experiment or the study conducted in an ethical manner? Is it free from cognitive bias? So the scientific method has a check on it, and those check are these peer reviewers. Okay. You don't have to know too much about the peer reviewers. I do want you to understand the concept that that's part of the scientific process, but you don't have to write everything down on this slide. If you'd like to pause, that's fine while you take some time to take notes on this. Okay, a theory is just an explanation of a behavior, an event, or something you think is happening, and it's a way to organize observations that we've made. So you might have a theory that, for example, the color yellow makes people happy. We do have theories that when people look at different colors, it evokes different emotions. That's a theory. Now, a theory itself, I'm going to use one for most of this class. I'm just going to use a theory that sleep improves memory. And it comes out of observations that people that have really good sleep habits often do well at test time. When you go observe people in a testing situation, those that are falling asleep during the test are probably sleep deprived and they don't do as well. So it's just a general theory. Now, a theory like this, like any theory, can give rise to a hypothesis, a testable prediction. And that's what a hypothesis is. So if we have the theory that, sleep and memory are somehow linked, oops, sorry about that, I could come up with a hypothesis: when sleep deprived, people remember less from the day before. Now, that's a great hypothesis to test the theory. But all hypotheses must be testable. And that means that they must be falsifiable. What does falsifiable mean? It means that they must be able to be proven to be false. You can have a hypothesis, but if I can't prove it to be false, then it's not a testable prediction. It's not a true hypothesis. I can absolutely prove that it's false, that when sleep deprived, people remember less from the day before. But let's look at some examples of non-falsifiability. The reason I'm going to skip this is I can't show the video when I'm doing a video, but we'll look at it when I get back. But remember, falsifiability is able to be proven false. I'm going to go on to the next slide here. Okay, here's some examples of non-falsifiable hypotheses. God created the heavens and the earth in 6 days. I can't prove that. Okay, even if I found evidence that it would take longer than 6 days to create the earth, I still can't prove this to be false. A philosophical concept like absolute power corrupts absolutely. I can find evidence to the contrary, that there are people who have absolute power and they're not corrupted absolutely, but I still can't prove it to be a false statement. An unverifiable statement: there is good in everyone. I can't verify that. I mean, I can certainly find people that I don't see any good in, but I can't tell you that there is no good in that there is good in everyone. And I certainly can't prove this to be false. And then certainly any claim about the future, like in the future all diseases will be cured. I can say, well, there's just too many diseases. There's evidence to the contrary that your body will morph to come up with new diseases, but I can't prove it to be false. So it is rare we're going to come across this in this class. I just want to make sure you understand that hypotheses have to be falsifiable. Okay, so we've talked about a theory and we've talked a hypothesis, and we're going to talk a little bit about research, starting with if I were to actually create a hypothesis, which we've already done in this class, and we're going to define the variables, or we're going to identify the variables, how would you go about conducting the procedures? So I took that hypothesis that when sleep deprived, people remember less from the day before. And I'd like you to just make sure you would know that the variables being studied here, and you should be able to identify variables through a hypothesis, are sleep deprivation, when sleep deprived, sleep deprivation, And then memory. That's the other variable that we're studying. So I need to study, and I need to, if I'm going to conduct an actual experiment on this, I have a hypothesis, and I'd have to be able to understand what is sleep deprivation and what is memory. When I talk about I need to understand what they are, I'm really talking about how do I define them? What are the precise parameters of how I'm going to manipulate sleep deprivation, control sleep deprivation, measure sleep deprivation? How am I going to measure memory? Okay. Operational definitions, good operational definitions in a study will be quantifiable. They will be represented by a number. Okay. So sleep deprivation and memory. I'm going to keep that in mind. And keep in mind that operational definitions must be quantifiable. So what does it mean to be sleep deprived? That's me. How will you test memory? Those are questions when we talk about operational definitions. Okay. How will you do that? So we'll get into how. We'll do some exercises, but let's also talk about why they're important. So operationals are really important because they're part of the scientific process. When you can do a scientific study, you don't just do it once. It gets replicated, it gets repeated. You want to repeat it to see if the results are consistent, if they hold true at a separate time to make sure there was no bias in the original study. And I can't repeat a study unless I understand how it was conducted. I don't know, what is sleep deprivation? How did you test memory? I need to know that. So before we do that, let's just practice with something else. Let's practice with the idea of how do you quantitatively measure, operationally defined, but quantitatively measure anxiety. If I want to gather data that's numerical about anxiety, how would I do that? How would I know that somebody's experiencing anxiety? Now, one thing we could do is that we could measure certain hormones that we know are released into the bloodstream when somebody is anxious. And I could actually tell you what percentage of, probably grams or whatever, are in the blood per liter. And I would be able to give you a number, and then I could measure how much cortisol, and we would know that the more you have, the more anxiety you might have. But we could also just as easily self-report. We could ask people, either on a scale of 1 to 5, or just ask people, do you feel not at all anxious? Do you feel a little anxious? Do you feel anxious? Do you feel moderately anxious? Do you feel very anxious? Do you feel extremely anxious? And I could put it on a scale of 1 to 5, 1 to 7, 1 to 10. Now that's done frequently, and the use of a scale like that is called a Likert scale. And you might have not be familiar with the term Likert, but you're going to become very familiar with it. But I know that you are familiar with doing surveys and questionnaires. It's certainly for MCPS. And they often, even though you don't use a numerical scale, you're often asked to answer something somewhat disagree, totally, extremely disagree, extremely agree, etc. So, and those are just translated into a scale, like a number. You may not see it as the person answering the questionnaire, but the researcher has a number behind each of those. So I'm just going to show you another example of a Likert scale. So these Likert scales are, like I said, used in questionnaires. They're used in surveys. They quantifiably, they give a numerical measure of a behavior. They give a numerical measure of somebody's attitude or opinion. Now, these are some examples. Like, for example, you might ask how severe is somebody's symptoms. On a scale of 1 to 5, how much pain are you in? And you may have seen that at the doctor's office. For little kids, they don't say 1 to 5. They say just, touch the face that shows how much pain you're in. And the doctor translates that into a number. The level of agreement with a statement. So they'll give a statement, they'll say, extremely, disagree to, strongly disagree to strongly agree, with maybe 2 or 3 options in between. The number of times, the number of hours, the number of days in which a person engages in a behavior. How frequently in a day, like if you're trying to see if somebody has obsessive compulsive disorder, you may ask them, how frequently in a day do they wash their hands, okay? Or find themselves organizing their information. And there's so many more examples. Okay, but I want to show you this example. This GAD, this is for generalized anxiety disorder. Generalized anxiety disorder is a disorder where people have anxiety about lots of different things. And it's not like super, super anxious all the time, but it's anxious, not necessarily, but it's anxious about a lot of different things all the time. So you can see here, this survey uses a Likert scale from not at all to nearly every day. And each of those responses is assigned a number, so it's quantitative. And you can see there's 7 statements and people have to respond to it. And then they get a total score. They add up all the columns, they get a total score. And that total score will determine the extent to which they might be diagnosed with generalized anxiety disorder. So this is a very common example of how psychologists use it. They use it for anxiety, for depression, for OCD symptoms, for Tourette. If somebody has a movement disorder, they have another survey for that. So I'd like you to create your own question. I'd like you to make use of a Likert scale. You don't actually have to use the numbers. Of course, you'll assign numbers to each response. But how would you assess a person's sleep habits? Let's go back to the hypothesis we had. How would you know if somebody, for example, was sleep deprived? What question would you ask, or questions might you ask? But just do one question. And it should have a range of responses that would, of course, be assigned a number. So go ahead and pause the video here and create your own Likert scale. Okay, you've practiced operational definitions, you've practiced creating a Likert scale. So the question is, how would you operationally define, going back to our hypothesis, sleep deprivation and memory? Okay, remember the hypothesis was that sleep deprivation would impede somebody's ability to remember something from the day before. So you're basically creating a set of procedures by operationally defining these variables. How are you going to collect this data? How are you going to measure this data? How are you going to manipulate this data? Start with sleep deprivation and then go to memory, okay? So I'd like you to stop here, take some time to do that, see if you can come up with quantifiable operational definitions for these 2 variables. Pause the video now. Okay. Oh, I should have said that specifically previous day memories, but hopefully it won't matter. But let's go ahead and take a look at this. So I came up with my own operational definitions. They're not perfect and they're not the only ones, obviously. I decided that I was operationalizing sleep deprivation is less than 4 hours of sleep between the learning and the memory test. So it had to be I should have said over a 24-hour period. And then I decided to operationalize previous day's memory as the number of items correctly recalled 24 hours after first seeing items. So it could have been a list of items, but whatever. Right? This is generally what we're talking about, and I have quantified these. Okay, so we've talked about operational definitions, okay, and we're moving on to, at this point, the benefits and the limitations of non-experimental research. We'll take a look at different non-experimental research and what role they play in the scientific process. And we're going to look at the features of non-experimental research methods. Now I'm going to stop here, and I would suggest that you stop for the day. Hopefully we got through this on the first day, and we'll pick up the next tomorrow.